I was interested in how evolution and reinforcement learning could be integrated, whether evolution, if it was the case that there were things replicating in the brain, whether that actually could improve machine learning.
And we are calling it iPhone.
Base model will do 0 to 60 in 1.9 seconds.
As a kind of an Apollo program effort for artificial intelligence.
Hey guys, welcome back to Tech Savvy. I'm Chrisantha.
I'm CD Athurali.
This is a very special episode of Tech Savvy. We have our first guest ever on the show, and we were fortunate enough to have an interview with this really amazing person maybe like a couple of weeks back. So we are excited to bring this episode to you.
I'm probably not the best person to introduce him, but just as a formality, he's Dr. Chrisantha Fernando. He's a senior research scientist at Google DeepMind. He was here to talk at AI Asia 2018, which happened a few weeks back.
So we have to warn you a bit because unfortunately we had some technical issues during the recording of this episode. So at some points of the interview, you might find that the audio quality is a bit low. There's a bit of noise in the background, but still we hope that you will enjoy this episode.
I was born in Sri Lanka. I left here when I was about 4 to England, and then I sort of started programming, I think, around 7 on a ZX81, which is a computer which has about 1K of memory, and you had to program in the computer programs that you bought from a magazine, the games, and did that and learned a bit of basic, with go-to statements and all that stuff. But then I didn't really know what to use programming for a while. I didn't know what to program. So I then, coming from a background of having quite a lot of doctors in the family, ended up doing medicine. Finished that, but then my friend was doing a MSc in Sussex in Evolutionary and Adaptive Systems, which is at COGS, this interdisciplinary research unit, and I became interested in basically this thing called artificial life, which is the study of life as it could be rather than life as it is, and ended up working through this evolutionary biologist called John Maynard Smith with a professor in Hungary called Chrisantha Mari, who they wrote a book together called The Major Transitions in Evolution. And I ended up working the origin of life at a postdoc in Hungary at the Institute for Advanced Study there on a model called the chematon, which is a model of the minimal living system, which is a metabolism, a boundary, and an informational control system. And it was through working with Ursh that we came up with the idea of Darwinian Neurodynamics, which was basically the idea that evolution might take place in the brain, sort of overnight. And we looked at mechanisms by which that could happen, and we had computational neuroscience models. And I suppose it was to study that at an algorithmic level rather than an implementation level that I came to DeepMind around 2014.
So how did you get to DeepMind from your research background?
Because I was interested in how evolution and reinforcement learning could be integrated, whether evolution, if it was the case that there were things replicating in the brain, whether that actually could improve machine learning. It's one thing to sort of demonstrate that something is possible biologically. That's one approach. It's another thing to demonstrate that algorithmically it's of use. So I felt that it was important to address that question. They had a website. It only had one web page at the time. I think it said DeepMind, and there was an email address. So I wrote to that. And I had a few interviews, and and Demis was very keen on integrating evolution with what DeepMind was doing, even at that early stage. So,
right. First, what did you start working on at DeepMind?
Well, I worked on initially evolution, trying to look at what evolutionary methods could do on their own. And then I basically moved into combining evolutionary methods with reinforcement learning, as I felt that would be a more powerful approach.
So one of the things with evolution is that it works when you've got a small number of parameters compared to a large number of parameters. Although recently Uber and OpenAI got models where they have evolved the same models as reinforcement learning frames. It's not as data efficient as reinforcement learning, but it is possible, especially with things like natural evolution strategies, which are variant strategies where you don't have a specific representation of the population. You just parameterize the distribution. You change the mean of the variance of the exploration distribution. But so I initially was just working purely with evolution, looking at how that could compare. I sort of found that I found that a little bit unproductive. I thought it would be better to try to mix these two methods, evolutionary methods and reinforcement learning, to exploit the benefits of each. And I think over time many people have done that in very many different ways now. So the initial work trying to evolve the architectures of neural networks, and there's a publication on that from some of my colleagues and I, evolved architectures, and that's recently been a bit of a sort of cottage industry. People doing that, like Mr. McLean, Google Brain, other people. There are several papers now involving neural architectures, and there's another bit of work. Convolution by evolution that we produced. This is where we took Ken Stanley's idea of composition of pattern producing networks. These are meant to be a sort of model of development. So it's a little network where you feed in the XY coordinates of the neurons in a bigger network. The little network outputs the weight between those two neurons. So you feed in all the possible weight coordinates about neuron coordinates, you get the weights, and then you have the big network. And that network can train, and the errors can be back-propagated into the small network that generated the big network.
I'm also quite surprised that this idea works.
Yeah, it does. It does. And then, so we managed to get something that was beautiful. So we call it convolution by evolution because the small network actually discovered very regular receptive fields with weight matrices and kernels, effectively in the big network. Effectively, we discovered to move a little patch around over the image in the big network. So it sort of discovered basically convolutional neural networks inside feed forward neural network. So that was quite beautiful. Anyway, the idea was then simplified and made much better by my colleague David Haar, who's at Google Brain, who just took the evolution bit out of the little network and then called it hypernets, and that was a much more popular application. So he just didn't even need evolution in the small network. He just had more CPD. And that actually achieved state-of-the-art results in various domains using the small network to encode weights on LSTM. So that's a nice example of how the sort of proof of principle was extended. So that was pretty good. And then I got into the idea of path, which was a long process of development. So this was the idea that if you have a giant neural network, imagine network with 1,000 times the number of parameters that we usually have. How can we train that? So one idea we came up with was that maybe you could have a network where the user has a population of pathways through that. Each pathway determines which subset of the network is trained. But it's still one network. So you evolve the pathways and train those pathways. Then you do binary tournaments between pathways. So you try two pathways out. If this one has a lower loss, then the parameters don't get destroyed, but the reference pathway gets destroyed, and the good one replicates the mutates. So you have a variant you may have as a bypass the good pathway. And so the pathways eventually converge to training the sort of parameters that are good on that task. And then what I do is to fix those parameters. You don't have to do this, but I fix those parameters and then reinitialize the sort of pathways and train them in another Atari game. And I found that on average, you could learn that second Atari game faster because the system learned to reuse the fixed parameters from the first game. It wasn't a massive effect, but it was a definitely effect. And then I've actually tried doing lots of work on that since. I noticed that one of the important things was that in a given layer, I had both normal linear things with non-linearities, but I also had skip connections and residuals. So the pathway was able to basically determine whether to use a skip or a residual or a normal layer. So it actually did kind of embedded architecture search that was being set up, where you weren't throwing away all the parameters, right? Yeah. So that's quite a lovely thing.
One thing I'm interested in, like how long it would take from starting from the beginning. Like typically, we know as they come with a new market, especially like a lot of experimentation. It's sometimes it's really hard to get these things to converge. So how long it took and how hard it was.
So I tried it with. It took a while. It took about I think 6 months to a year to get it to work. And I tried it with simple things like just MNIST. Actually, I tried it with so everything you should try with MNIST. So basically, I tried it with, for example, binary classification. So I showed it 5s and 7s, or 9s and 8s. There are also possibilities, and then saw how well it transferred to like 8 versus 4. So if it's learned to distinguish 8 from 7, does that? It's found a pathway. Does it help then? Is it faster then to distinguish 7 from 8?
Yeah.
Sorry, 8 from 9. So tried it with that, and then I extended it to Atari. So I think it's really important in research to have a rapid turnover of algorithms. So you need to be trying with very small problems where you can find out whether it's worked in about 20 minutes. If you have to wait, I personally am very patient. I can't wait longer than about 20 minutes to work out whether something actually runs and it has an effect. Some people are more patient.
Yeah. We sometimes have a lot more patient than resources.
So this I just did locally on my CPU. Just these initial things were just on one CPU. These initial investigations. Otherwise, it's very hard to iterate on an algorithm.
So on that, I think it was most recent significant contribution.
I think so. There have been other.
Anything coming up?
Yeah, there have been other things. So pathways resulted in that. Like there are about a year or so, it's about 101 citations. So it's there are many variants with it. It's the principle of trying to use subsets of modularity. Principle of modularity in neural networks is not being solved. That is a modular reuse skill. This is an unsolved problem.
Initially, I was not thinking to ask this question, but this came up. I'm interested in knowing some piece of work to be groundbreaking. Is there anything is it only hard work, or do you need a little bit of luck as well? Like, because I've seen arguments that saying, especially the research coming out from companies like Google and Facebook, since they have a lot of PR as well, even with their research teams. So is there any effect, or like if someone is actually doing hard work or coming up with a good idea, so do they have equal opportunity?
You need to have how to write a paper. This is one of the issues, just how to write a research paper. There is some good material actually from the that African endowment about. It was a talk by Ulrich, my colleague, on how to write a research paper, which everybody can look at. Yes, I think make a reference. But the first part of your question about research, I suppose one strategy is to have about 10 problems in mind. So to discover about 10 issues that you feel need to be solved. Then, whenever a method becomes available to solve one of those problems, you just drop everything else and work on that problem to focus your attention. This is the principle by having. So that's one idea. I think knock some stuff out. If something is going to work, it should work fairly easily.
And then if it does, then I put some more effort into it. It's either that, or I have a strong theoretical belief that some strong bias that it should work, and then I put lots of effort into it, and that can be a little bit of a waste of time sometimes. But it could not work for 3 months, and then it never works. This happens as well. I'd say, there's different ways of doing it. I mean, sometimes you just know something should work, and then you put effort into that just to get it working. I often don't work like that. I tend to, but I mean it's nice to be in that position where one can do that much exploration. But you have to work. I mean, okay. So another major thing is just talking to people to understand. Because there are sometimes lots of little reasons why things don't work. You haven't normalized something, or it's not the right representation of the inputs. There's so many little tricks that where an idea could work in theory, and it just needs a little bit of you haven't got the right architecture. You needed 2 layers instead of 1, or there are. So it's worth being able to talk to people that have practical understanding of neural networks to get some advice on that. I'm very lucky that I can do that.
From our little experience, we know that some of these things are very much important to understand the practical aspects of like the actual implementation, like the architecture, maybe one single parameter, the value it should have, these are the things.
Wow. So that reminds me. So that there was I was able to work with Max Jaderberg and other people to develop, helped out a little bit in developing population-based training. So this is the idea of using evolution to evolve the hyperparameters of a neural network for training, but not throwing away the parameters while you're doing that. So you have like 20 copies of the network, you train them all up, then you do binary tournaments between those copies. The one with the lowest loss overwrites the one with the overwrites the one with the highest loss. That is, you copy the parameters over, but then you mutate and copy over the hyperparameters. So you're not throwing away all that training. Compared to doing a grid search. So it's like Lamarckian evolution of parameters and Darwinian evolution of the hyperparameters. And that's being used very widely. It's extremely useful in developing new algorithms. If you can get about, and I think this afternoon when we do our technical thing, I think we'll try and maybe implement that for this RL setup we've got. We may not finish it, but let's just start it. Let's just start doing that. Yeah.
So since we were talking about research, I'm more interested in about probably for listeners knowing that how important it is to focus on fundamental research, especially why all these companies are putting a lot of effort into fundamental research, why they recruit scientists to work on these problems, the importance of it, especially for a country like Sri Lanka, why the industry also needs to understand the importance of working with probably academia and focusing a little bit more on research.
Yes, because there is a tendency, I suppose, in countries like Sri Lanka for the work to be applied. So you take some local problem like dengue or whatever, and then you apply known methods to try and solve that problem. There's definitely a role for that. But I think there should also be, so that's often quite industry driven maybe, but there's also a role for fundamental sort of blue sky research, simply because I think that helps people understand the algorithms better. So then they become better practitioners even on the applied side, right? And also I think machine learning at this stage, there is still a lot of exploration to be done. There's so many different techniques available, and we haven't tried all the combinations. And there are sort of fundamental insights that are still lacking. So it's not just an engineering task; it's a scientific task. And I don't think it requires large data sets to come up with new insights, such as looking at all the work on intrinsic motivation that's happened recently is one domain, or structuring exploration. I don't think things like issues about hierarchical reinforcement learning, these kinds of things still need a lot of theoretical work on them. So meta-learning is one big thing. So I was helping to organise the meta-learning conference at NIPS along with some
last year
along with some colleagues, and that was very natural for us because evolution and reinforcement learning is a kind of meta-learning setup.
Yeah.
So we had some discussions about what meta-learning is. So recently there's a paper where Sergey Levine and God, I've forgotten the other author's name now. Is where we used evolution to initialize the initial parameters of the neural network before training. So we took a distribution of tasks, the same set of tasks as this other paper on meta-learning, and we used evolution to initialize the parameters and then use normal learning. And we found basically something called the Baldwin effect, which is a principle in evolution where learning guides evolution. So that was very interesting. And recently, not DeepMind, but another set of researchers have come up with this idea of evolutionary reinforcement learning, which is where you have a population of policies that are evolving in the standard way and a reinforcement learning algorithm, and the population generates experiences which are then put into the replay buffer of the RL algorithm, and the RL algorithm then puts policies back into the evolving population.
Yeah.
So this does two kinds of exploration. So I think we've only scratched the surface of how evolution and reinforcement learning can be combined.
Yeah. When we look at some of these ideas, after when we look at them, some of these are pretty obvious when it is published somewhere, and also some of these are not so obvious. We are very surprised how this person came up with this idea. So I think it's a mix of things.
All good ideas are obvious after they've been
I think that is the case. Yeah.
You kick yourself and think, why didn't I think of that?
Deviating a little bit from that, one thing I would like to know is, like, to do research, especially again in a country like Sri Lanka, other than the self-motivation, what should be the ideal reward for a person to be involved in maybe a fundamental research? So we are actually thinking of ways to encourage more produce high quality research and get it published at maybe top tier conferences.
So in the meeting today, there's been a discussion about this. So one idea is, because in Sri Lanka it seems that in the university sector there isn't much of a focus on research, because people are strapped for time and resources, right? And teaching is so important. So, and also in my experience is that as a lecturer, I was lecturing for a couple of years at Queen Mary, that if you get grants, then your teaching load goes down. You have more resources to buy equipment and to have PhD students. So if you win a grant, you get PhD students, you get postdocs, right? So the lecturers are competing for those resources. So this is like an evolutionary system, right? And that doesn't seem to happen here. There isn't is that right? There's no competition for. How do lecturers compete for PhD resources?
I might not be the best person to. Okay. I am also not very aware of that.
Right. So it'd be interesting to find out and work, and because so that getting research off the ground at universities might be hard because of the resources. So one option is to have this kind of centre of excellence for machine learning research, which may be a sort of virtual centre of excellence, but
again, my argument there is, especially in the machine learning and AI, you don't need a lot of resources to at least begin with.
No, you don't. I mean, you can use Google Colab, which gives you one GPU. I mean, that's incredible, isn't it? But you can only use it for 12 hours, apparently.
Yeah, but that is also
that's
fine.
Still pretty good.
You can optimize for that one.
Yeah.
But I think there needs to be a little bit of mindset change as well. Like, people need to, it can be even called as a different thinking.
Yes, it's about questioning and disagreeing, isn't it?
Yes.
And
the discussions. What I really don't see here is the genuine discussions around these topics. People are doing their own thing. But what I've experienced in the other parts of the world is they are generally
having critical, but friendly interaction. So that's the notion of psychological safety. So for a group to work, this is well known in management now, isn't it? that you have to be able to disagree with each other in a friendly way.
I think that is even in our education system, I don't think it is very much encouraged at the moment, but hopefully it would change. But I think we need to start from some point and keep on improving from there. I think there are a lot of aspects for us to understand, but maybe the immediate thing we can do is like focus a little bit more on the reward or the motivation.
Right, let's do that. Okay. So there could be prizes for international publications at top tier conferences, and these could be funded by both government and business. Significant prizes with the name of given the name of a famous Sri Lankan researcher. Give me some names of some famous. Who are some famous Sri Lankan researchers, actually?
I don't want to mention names because it can be a little bit biased. My personal bias would be there, so let's not name anyone. And I have my personal opinion.
Do we not need someone to name the prize after?
Yeah, there are actually some prizes. Like at every university, there are prizes.
I see.
Named after.
It doesn't need to be machine learning.
So I would call these people like definitely they are senior, even though I'm not sure how.
They might even be dead.
Yeah.
I mean, it's totally okay to use a dead famous person.
Typically, that is the case, I think, as far as
most people are dead.
Yeah.
Yes.
But again, at least to me, like even getting a publication at a top tier conference, that itself should be a pretty good prize.
Well, it should be, yes. But is it?
That's the problem, I think. So we need to create that, and people. I don't think a lot of people even know about these things and how these things are evaluated elsewhere. So I think we need to create that awareness as well, and hopefully with efforts like the event yesterday and today, so we'll also be able to create this platform between experts like you, where you will be able to contribute as time permits.
That was one thing that was discussed. The idea that I'd be very happy to try to help out in sort of thinking about research projects and stuff. Definitely, that would be a reasonable investment. And it wouldn't be much time, I think, for people to like present possible things, and we can have like an hour-long virtual discussion about research topics, right? Every now and again, every few months or whatever. So that'll be. I'd be very happy to help out like that. Yeah.
I think it is quite important, like both to get the exposure as well as that high level direction of like, and also I think one of the biggest problems we have is like there are very little people who are at the cutting edge, who understand the state of the art even in their field. So there's in my opinion, there's a huge gap between their understanding, their knowledge, and what is actually happening at the moment.
I suppose one thing to do is just to encourage leadership, so getting people who can actually teach machine learning and giving them resources, like helping them, go to conferences and so forth, so that they can actually themselves become local leaders, experts themselves. Yes.
Yeah. Okay, I think that is a good set of recommendations, suggestions. Hopefully, we'll be able to see a lot of progress. Hopefully. But it can be very slow.
Sure.
As long as we set the right trajectory, at least, we'll be making progress towards that direction. So probably the last thing I would like to go back to the AI, or the DeepMind's focus is purely on artificial general intelligence. Like we would like to, probably our listeners would be very much interested in knowing what is not necessarily a definition, but where are we heading? How close it is, or how far away it is, and what are the benefits?
So I say artificial general intelligence is being able to. It's basically what a child has. So a child, when it learns tasks A, B, and C, becomes better at doing task D. In a very general way, D doesn't need to be trivially from the same distribution as A, B, and C, but it can be quite different, and still the child can learn it faster. We don't really understand how that kind of transfer learning is possible, what's needed for that. So if you take the DQN on Atari, for example, it doesn't become faster at learning the second Atari game if it learns the first. So that's one aspect of artificial general intelligence. I suppose another aspect is that agents create their own problems. So there's been a lot of work on solving problems here, whereas for real intelligence you have to create your own problems as well. So that's one aspect, another aspect of it. So yes, I think that's what AGI, that's how I think of AGI.
So some of the concerns like from the mass especially is like they are somewhat concerned about like once we solve the artificial general intelligence, would that be a positive thing or a negative thing? I think we are yet to define these things, and there are a lot of problems to be solved. Even before that, there are like the problems, like the machine bias. These are, I think, more near future problems we might face as we keep on getting AI technologies integrated to our lives.
Talking about the approach of DeepMind towards AGI, we saw reinforcement learning, and then with AlphaGo, and then we saw AlphaGo 0 where it learned by itself. What's next for DeepMind towards that goal of AGI?
Hope you're okay with sharing that.
Yeah.
Well, I can definitely answer the first question, which is that I think the discussion about safety is one that everybody is responsible for engaging in, especially people. I mean, both people in with expert knowledge and people without. I think we all have to have a discussion about that, and we're actually publishing papers on that subject of AI safety, looking at under what circumstances a reinforcement learning algorithm will have its values aligned to the designer, things like this. And so there's actually theoretical work on that kind of question. So yeah, I mean, I think we all have to discuss those questions as a community.
The way I justify encouraging the local efforts, the way I justify it to myself is that we also need to understand like every part of the world, like all these people need to have some understanding about what is going on, because these things will be very much integrated to our lives, and only we know what are our problems. So we are the best people to represent our problems in this.
Yeah.
So yeah.
And for that, I suppose it's useful that it's our responsibility to help people know what the capabilities of AI now are. And so it's difficult to predict the future and how long AGI will take. I don't think such predictions mean much in the sense that there are sort of still unanswered scientific questions, you know. It would be like asking, I don't know, Ptolemy how long he'd think it took before we understood the proper dynamics of the solar system. I mean, it's difficult.
Yeah, I also think that there are a lot of questions even before defining certain things like artificial general intelligence. Okay, I think that's a very interesting conversation.
Thanks very much for inviting me.
And we are actually honored to have you as a guest, as well as thank you very much for accepting our invitation to be a part of all these sessions happening yesterday and today, and hopefully in next couple of days as well. And hopefully we'll be able to talk to you in future as well, and you'll be engaging.
And I look forward to our technical stuff this afternoon.
Yeah.
Yes.
Today is 8th November, because we'll be publishing this later on. Okay, I think anything to add?
Yeah, I think we had to give a shout out to Slascom and Jeevan and everyone who has organized this AI convention, and everyone who is involved.
I really appreciate and admire Jeevan's vision to promote this type of technology, especially in a country like Sri Lanka. I personally was not expecting that type of engagement from the top.
Yeah.
So it's very encouraging to see that even to host someone like you, we didn't have that capacity. But these are very good enablers for us to do a lot more things in this space.